Hey there, curious minds. Have you ever dropped your phone and watched it race toward the floor before your heart could even react? That, my friend, is free fall, the purest form of gravity's magic trick. When an object falls only under the pull of Earth's gravity and nothing else, not air, not wind resistance, we call it a free fall. The acceleration that acts on it stays constant near Earth's surface, about 9.8 meters per second squared, always pointing straight down toward the center of the Earth. Imagine tossing a ball from a tall building. Whether it's a tennis ball, an iron ball, or even a watermelon, in vacuum, they'll all hit the ground together. Shocking but true. So the next time you drop something, remember, it's not just falling, it's performing a beautiful dance choreographed by gravity. Alright, let's talk about this mysterious letter G, the acceleration due to gravity. It's the rate at which an object speeds up as it falls freely toward the Earth. We calculate it using the formula G equals G multiplied by open bracket m divided by r squared close bracket. Here, G is the universal gravitational constant, m is the Earth's mass, and r is the Earth's radius. Plug those in, and we get G is 9.8 meters per second squared. Now, here's something cool. G slightly changes depending on where you are. Go up a mountain, G decreases. Move closer to the poles, it increases a bit. So technically, you weigh a little less in Shimla than in Chennai. Not enough to skip gym though. Now that we know gravity gives constant acceleration, let's see how it affects motion. The good old kinematic equations still work, but instead of using A for acceleration, we use G. So here we go. V equals U plus G times T gives us the velocity after a certain time. S equals U times T plus half gt squared gives the distance fallen. And V squared equals U squared plus 2gs links velocity directly to displacement. If the object starts from rest, U becomes 0, which makes the math super easy. So basically, if you know any two of these, time, velocity, or height, you can find the third. Gravity's equations are simple, elegant, and always dependable, just like your favorite science teacher. Let's solve a real example to see how this works. Say you drop a ball from a height of 20 meters, that's about the height of a 7-story building. You're asked, how long does it take to reach the ground, and with what speed? We start with the equation S equals half gt squared. Substitute values 20 equals half times 9.8 times t squared. That gives t squared equals 40 divided by 9.8, which is roughly 4.08. So t equals 2.02 seconds. Now to find velocity, V equals U plus gt, that's V equals 0 plus 9.8 times 2.02, which gives 19.8 meters per second. So the ball hits the ground in just about 2 seconds with a speed close to 20 meters per second, that's nearly 72 kilometers per hour. And that's why even small drops can hurt, gravity doesn't mess around. Alright, let's wrap it up like true physicists. Free fall is when an object moves only under gravity's pull, no other forces. Acceleration due to gravity, G, is about 9.8 meters per second squared and depends on Earth's mass and radius. We use the same motion equations, just replacing A with J. In a vacuum, all objects, no matter their mass, fall equally fast. Remember Galileo? He dropped spheres from the Leaning Tower of Pisa to prove this centuries ago. And today, astronauts on the moon see it happen for real. Everything falls together. So next time you see something drop, don't just panic, appreciate the elegance of physics at work. Gravity isn't just a force, It's the reason we are all grounded, literally. See you in the next session where we'll explore another fascinating law of nature and maybe have a little fun with it too.